Let's talk about integrals related to inverse trig functions. Now, there's two main antiderivatives we really need to memorize. The first is that the antiderivative of 1 over the square root of 1 minus x squared is arc sine of x plus c. Don't forget the plus c for the most general antiderivative. So let's highlight that because this is something that we for sure want to memorize, okay? The other big one that we want to memorize is the antiderivative of 1 over 1 plus x squared, and that is arctangent of x plus c. Okay, so I'm going to highlight that as well. These are the two big ones. Now, I want to work through a couple of examples with you. For example 8, we have a definite integral. We can tell it's definite because you got these limits of integration over here. And the first thing I'm going to do is I'm going to take this integral and I'm going to rewrite it slightly. So this is going to be the same as the integral from 0 to 1 over 4, 1 over the square root of, and what I'm going to do is I'm going to take this 4 and I'm going to absorb it under the square. So the square root of 4 is 2, so I'm going to slide that 4 under the square. I'm going to get 1 minus quantity 2x squared dx. So this is a pretty standard kind of trick we're going to be using, is this whole idea of absorbing something into a square. This we do a lot. And you don't even really need this this number 4 to be a perfect square. If it was like 5, you could just move it onto here and put this square root of 5, you know. Now that I have that, what I'm going to do is I'm going to use substitution. So I am going to let u be equal to 2x. In other words, I'm going to substitute this term right here. And when I do this substitution, I know that I need to calculate the derivative. So this means that du dx would be just 2, or dx is equal to 2 du. Now, not only do I need to change the variable, but actually I need to change the limits of integration. So when we have the 0 here, that really means x is equal to 0. And in order to figure out what the corresponding u should be, I'm just going to substitute in 0 anywhere I saw x into that u equation. And then this gives me that u is equal to 0. I do the same thing with x equal to 1 over 4. And that would make my u equal to 2 times 1 over 4, which is equal to 1/2. Okay, so now this integral becomes, okay, so let's make our substitution. So our integral now becomes the integral from 0 to 1/2. I'm going to have 1 over the square root of 1 minus u squared. And then I replace my dx with the 2 du. Okay. In other words, this dx right here got replaced with, I remember I solved for dx, that was 2u, so I put that 2u right there. So I can factor out this 2. So now my integral becomes, factor out the 2, this becomes the integral from 0 to 1/2, 1 over the square root of 1 minus u squared du. Now we could see that the integrand is exactly the integral that we wanted to memorize. This is the antiderivative of arc sine. So this becomes 2 arc sine u, and we evaluate that at 0 and 1/2. So we're going to have 2 arc sine of 1/2 minus arc sine of 0. Now, arc sine of 1/2, that's equal to pi over 6. Arc sine of 0 is just 0. So 2 times pi over 6 is just pi over 3. So we get a final answer of pi over 3. Okay. Let's take a look at another example. Example 9 is a classic example. The first thing that I want to point out to you all is that this letter A is a constant. So A is a constant. That's important to know. In other words, you see this dx here, that means our variable of integration is x. That means any other variable we see should be treated as a constant. Okay. Now, when I look at this, this looks pretty similar to my antiderivative that gives me arctangent, but that has a 1, and we have an a squared. So the first thing we're going to do is we are going to factor out the a squared from the denominator. Okay. And when I pull out an a squared from the denominator, what am I going to get? Well, I'm going to have the integral. I'm going to have a 1 over a squared. I'm pulling it out from the denominator. And let's see what we're going to get here. Because this first term right here does not have an a squared in it, I'm going to basically, when I factor it out, I have to divide by a squared. That way, when I distribute the a squared and the a squared are going to cancel out. And then the second term is just going to be a 1 because I factored out the a squared there. And then the dx just stays there, right? So in the next step, what I'm going to do is I'm going to do a couple things or a few things. The first thing I'm going to do is I'm going to factor out this 1 over a squared out of my integral completely. So I have a 1 over a squared out in front. Okay. The next thing I want to do is I'm just going to interchange the two terms on the bottom. So I'm going to put the 1 first. That's just going to make it look more like the antiderivative I have up above. And the last thing I want to do is I want to, I have an a squared and divided by x squared, or x squared divided by a squared. They're both being squared. So I'm going to put it all under 1 square. So this will be x over a squared like that, dx. So we're really close to being done here. I hope you guys can see what the next step is. The next step is that I really want to let u be equal to this term right here. So we're going to do substitution. Let u equal to x over a. This means that du is equal to 1 over a dx, or you could say dx is equal to a times du. So now we're going to make our substitution. So when we make our substitution, we're going to get 1 over a squared. You're going to have the integral of 1 over 1 plus u squared, and the dx gets replaced with a du. Okay? So we see I have an a. This is treated as a constant relative to u. So anytime you have a constant times your integrand, you can move the constant outside the integral. So this becomes a divided by a squared, integral of 1 over 1 plus u squared du. This front part simplifies to just 1 over a. And this integral, I hope we recognize that this is exactly the arctangent. So that indefinite integral becomes arctangent of u plus c. Now we're not done yet. Remember, our original integral had a dx, so we need to change all the u's back to x's. So I am going to rewrite both the question and the solution. We're going to get that the integral of 1 over x squared plus a squared dx, that's going to equal to 1 over a arctangent of x over a plus c. And I'm going to put a box around this guy. And I'm going to highlight this to encourage you to remember this example so that you can use this example in future problems. This integral kind of comes up pretty frequently in this class, so I think it would be good for you all to know this. All right, everybody, take care.